We have a square, ABCD. Our goal is to find the exact length of each side of the square. Let's call that unknown side length x. Inside the square is triangle APQ. Point P lies on the right side of the square, and point Q lies on the top side. Here's the key piece of information. Triangle APQ is an equilateral triangle, and each of its three sides is exactly 2 units long. Now, let's draw the diagonal of the square from point A to point C. This single line is the key to the entire solution. Because the figure is perfectly symmetric, the diagonal passes straight through the center of the equilateral triangle. Let's call the point where the diagonal meets segment PQ point M. Since the diagonal is the line of symmetry of the equilateral triangle, it bisects segment PQ, and it is perpendicular to it. That means M is the midpoint of PQ. Since PQ is 2 units long, both PM and MQ are 1 unit. Now, focus on right triangle AMP. Its hypotenuse, AP, is 2. One leg, PM, is 1. So let's apply the Pythagorean theorem. AM squared plus 1 squared equals 2 squared. 1 squared is 1. 2 squared is 4. Subtract 1 from both sides, and we get AM squared equals 3. Taking the square root gives us AM equals the square root of 3. Now let's look at the small triangle, PCM. We already know it has a right angle at point M. Here's another useful fact. The diagonal of a square always bisects the 90-degree angle at each corner. So the angle at C is split into 2 45-degree angles. That means triangle PCM is a 45-45-90 triangle. And in this special triangle, the 2 legs are equal. Since PM is 1, CM must also be 1. We're almost done. The diagonal of the square, AC, is made up of 2 segments, AM plus MC. So its total length is the square root of 3 plus 1. But there's another way to write the diagonal of a square. If each side has length x, then the diagonal is x multiplied by the square root of 2. Since both expressions represent the same diagonal, they must be equal. So x times the square root of 2 equals the quantity the square root of 3 plus 1. Finally, divide both sides by the square root of 2. That leaves us with the exact value of x. The side length of the square is the quantity the square root of 3 plus 1, all divided by the square root of 2. If you found a different approach, I'd love to hear about it in the comments. Thanks for watching, and I'll see you in the next video.